Let me show you how you convert 120 volts AC to DC. And along the way, we will learn why it comes out 170 DC if you put 120 AC into it. So AC, alternating current, is exactly that. It goes back and forth. DC is in one direction. The key to converting the back and forth into one direction is a diode. A diode is like an electrical check valve. It allows current to only flow in one direction and not back in the other direction. 120 volts coming off that hot and neutral. And it's hooked on an oscilloscope, and that's showing the back and forth. So half the time it's doing that, and then it flips, and the other half the time the current flows in that direction. I know a lot of people on Facebook are going to freak out that I just say current comes out of the neutral. But what we want to do is, when it gets to this meter, we want it all going in that direction. So let's put the diodes in to accomplish that. So this would appear to be the easy one. The path from hot, through that diode, through the meter, and back to the neutral. 120 volts in, but we're only getting 60 volts at the meter because the half of the cycle where it comes back out of the neutral is being blocked. And you can see that on the oscilloscope, that we only have positive numbers from one side now. We're missing half the humps. So now we want to make a path from neutral to hot in a way that when it goes to the meter, it still goes across in that direction. For the reverse path of neutral to hot, I've used red and green jumpers. So it starts on the red jumper, goes through this diode, across the meter, then it comes back on the green through this diode, over to the hot. Can you see all that? All right, let's check the meters. We're at 120 AC coming in through the diodes, 114 DC on the other side. And if we check the oscilloscope, we have successfully created all the humps are now on the positive side. But we have valleys. We haven't filled those valleys yet. And that's why in my original intro, we had 170 instead of 114. I'm going to show you how to fill the valleys. The peak of the humps is 170 volts. The way we fill in the dips is with a capacitor. And what a capacitor will do, as the wave is rising, the capacitor charges. And then when the wave drops, the capacitor discharges. And then the wave rises back up and charges it back up. So having a capacitor in the circuit will even out those valleys. Watch the humps as I connect the capacitor. It levels out, and we now have the 170 volts we had in the beginning, or 169.5 today. If you ever hear Electric Boom talk about a full wave bridge rectifier, that's what we just built. Thank you very much.